Hello guys, welcome to lesson 2. In lesson 2, let's now talk about your word normal limit. How do we solve normal limit? Very simple, freestyle. Now, let's say for example, we have a limit of lim 3x squared plus 5x plus 2. Now, first of all, this is the first part. Please pay more attention. In solving limits, the first thing to do is to just plug in. In as much as you don't have the two things we said, don't have zero, anything over zero in the base, and don't have negative in the square roots. If you don't have any of this, you are good. Two things to avoid. Now, how do we solve this? This is practically equal to lim 3 into 2 all square. I'm plugging as x approaches 2 plus 5 into 2 plus 2 as x approaches 2. So this practically becomes, what's 3 squared? And 2 squared, 4. 4 times 3, that's 12 plus 10 plus 2. That'll give me 12 plus 12, which is equal to what? 24. Very simple. Is there any problem with that? Just plug in. Did you get anything over 0? Did you get negative square root? No. Let's move to the next question. We're given that lim x raised to power 4 minus 27. Plug in. So this practically becomes lim 3 into 4 minus 27 into 3 as x approaches 3. So this now becomes, what's 2 raised to power 4? That's 3 times 3 times 3. 3 raised to power 4. 81, right? That will give me what? 81 minus, what's 27 times 3? Which is equal to what? 81. What's 81 minus 81? 81 minus 81 is equal to 0. 0 is an answer. Very okay. Are you seeing that? Let's take another example. Now, what of still we're giving lim t plus 3 all over t plus 2. Now, this now becomes lim t, which is 2 plus 3 all over 2 plus 2. What's 2 plus 3? That becomes 5 all over 4. Don't forget as t approaches 2. So what becomes the answer? 5 over 4. The 5 over 4 and answer is it. We said only two things that you must avoid. Anything over 0, right? And negative in the square root. So this is okay. Now let's see another question. We're giving lim x squared minus 16. Now let's plug in. This now become lim. That become 4 squared minus 16 all over 4 minus 4 as x approaches 4. So this now becomes 16 minus 16 all over 4 minus 4, which will be equal to 16 minus 16 is 0. I don't have a problem with that. All over 4 minus 4, 0. If I have 0 at the numerator, there's no problem. But having 0 at the denominator is bad. So this, because of this 0 in the denominator, this is wrong. What do I do? We'll now find other ways to avoid that 0. And what are the other ways now? Please follow me. Now, what are the other ways? Let's take this thing out. Now, this is the same thing as saying lim. If you watch, this is x squared. This is 16 is minus 4x all squared. Because 4 squared is 16 all over x minus 4 as x approaches 4. Now, if you watch, this is difference of 2 squared. Did you learn difference of 2 squared in chapter 1 when we were trying to learn my 5 bad chords? Now, this is the same thing. Difference of 2 squared says that if you have x squared minus y squared, it means x minus y, x plus y. So this is same thing as saying x minus 4 into x plus 4 all over x minus 4. So if I put that in lim, this is same thing as saying lim x minus 4 into x plus 4 all over x minus 4 as x approaches 4. From here now, this, if I decide to bracket it, this will cancel this. Although I have this now become lim x plus 4 as x approaches 4. Now substitute. This now become, anywhere you see x, put for that become 4 plus 4. What's 4 plus 4? 8. Did you understand what we did? When we find another way, normally in limit, you plug in. When you get an answer, you are good. If the answer is not against the rules, like the two things I told you to avoid, you can never have anything over 0, and you can never have negative in the square root. You are good. Are you seeing that? So, but if you plug in and you get that, find to retrace your step on how to solve it without getting such. Always retrace your step. Always what? If you have 0 at the base, always retrace your step. Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. Let's see question 5. The question says, now, let's plug in. This will give me lim minus 2 raised to power 3 plus 8 all over minus 2 plus 2 as x approaches minus 2. And that will give me minus 8 plus 8 all over minus 2 plus 2, which will give me 0, which is not a problem. But having 0 at the base is a problem. So this is wrong. We'll retrace our step, right? We'll find a way to factorize. So let's take this out. Now this practically saying, if you watch, this is practically saying x cubed plus 2 raised to power 3. And this difference of cube. And what was difference of cube? We take among the 5 part code. As I told you, learn that part code before we start. Now this is simple as saying x plus 2 plus we start minus will follow. X squared minus 2x plus 4. Remember when we talk about this? Yes. So putting that into the equation, it now become lim. Put this now, that become x plus 2 into x squared minus 2x plus 4 all over x plus 2 as x approaches minus 2. So this will cancel this. So it now become lim x squared minus 2x plus 4 as x approaches minus 2. And that will practically give me minus 2 all squared minus 2 into minus 2 plus 4. That become minus 2 all squared will give me 4. Minus times minus plus 4 plus 4. 4 plus 4, 8. Just like saying 4 plus 4, 8. 8 plus 4 is equal to what? 12. Are you with me? I'll give you bad codes. We'll move for the limits. Now, if you still you understand that, another normal limit, total people are giving s cubed minus 27. This now, how do we solve this? First of all, we'll plug in normal. Now, we'll add the first law. Anytime you see a limit, plug in. No fear, plug in. If you get 0 at the base, also, uso, or that is uso, also wrong. So it now becomes lim. This is same thing as saying lim. First of all, if you plug 0, if you plug 3 here, 3 squared is 9, 9 minus 9 is 0. So you're going to get 0 at the base, you should know. So I'll just go and find a way to factorize. This is same thing as saying s raised to power 3 minus 3 raised to power 3 all over x squared minus 3 squared. Is that correct? As x approaches what? 3. So from here now, this is same as saying x minus 3. That's the difference of cube now into x squared plus 3x plus 9 all over. This will give me x minus 3. So that's the difference of 2 squared, s minus 3 into x plus 3. So s minus 3 will cancel s minus 3. What do we have? We're going to have lim x squared plus 3x plus 9 all over x plus 3 as x approaches for 3. So this now substitute now, you're going to have, if you check, if you substitute in the base, you're not going to have 0 anymore. So you can substitute now. That becomes 3 all squared plus 3 into 3 plus 9 all over 3 plus 3. So that becomes 9 plus 9 plus 9 all over 6. And what's 9 plus 9? That's 9 times 3. 9 plus 9 plus 9. That's 27, right? That becomes 27 over 6. So like reduce, can anything go? 9 can go here. 9 here, 8. 3 here is 9. 3 here is 3 here is what? 2. So that's the same thing as saying 9 all over 2. Abi? So that becomes the answer. Now you can see that the 6 examples we have shows you that normally in limit you plug in, but if you have 0 at the base, you have to factorize. But what if the question is complex? I'll give you a bad code now. This is where my bad code now comes. Are you ready to learn bad code? Let's learn bad code. Please, you only use this bad code when you plug in and you have 0 at the base. Normally, when you see a question plug in, if you don't get 0 at the base or a square root as negative, you are good. But if you have 0 at the base, use this bad code. This bad code, don't use the bad code when you have not ensured that the denominator is giving 0. First of all, check. Now, bad code. If we have y is equal to raised to power n, this is the first law of derivative. It states that if we have y is equal to s raised to power n, multiply the power by the function, subtract from the power. That means y prime now, which is y derivative, is now equal to multiply the power by the function, that's ns raised to power n minus 1. Multiply the power by the function, subtract 1 from the power. Multiply the power by the function, subtract 1 from the power. Let's say, for example, we have y is equal to x squared. What will be y prime now? Y prime will now give me what? Multiply the power by the function, that's 2s raised to power 2 minus 1. That will give me 2s raised to power what? 1, which is simple as what? 2x. If you have y is equal to s raised to power 4, what will now be y prime? Y prime will now give me what? That's 4x raised to power 3. Multiply the function by the power, subtract 1 from the power. If we have y is equal to s raised to power 6, give me answer fast. That will be 6x, y prime is 6x raised to power 5. If you have that y is equal to 7x raised to power 3, what will it give you? That's 3 times 7x 3 minus 1. That will give me what? 21 s raised to power 2. Are you mastering it now? So we're going to differentiate. With this, you are good. Now, give me back those questions. Let's go back. The ones that, you remember this one, when you plug in, you're going to have 0 at the base. True or false? When you plug in, you have 0 at the base. Yes, look at the base. If you put 4 here, you're going to have 4 minus. You only use the bad code when it's giving you 0 at the base. So when I put I have 0 at the base, what I'm going to do, I'm going to differentiate. This now become differentiate this. That's, if you differentiate s squared, you are going to have that become lim. Differentiate s squared, you are going to have 2x. Now, minus, take note that this is a constant. The derivative of a constant is 0. Always take note of that. What is the derivative of a constant? 0. So let's go back and add it. If y is equal to 3, y prime will be equal to what? 0. Because it's a constant. Take note, what is the derivative of a constant? 3. So for me now, if you differentiate 2x, but if you differentiate 16, what are you going to have? 16 is a constant, so it's going to have 0. All over. Differentiate x, you're going to have 1. Minus 4 is a constant, minus 0. As x approaches 4. So this is same as saying lim 2x, because 0 means nothing, all over 1 as x approaches 4. If you plug in, this is same as saying 2 times 4. What's times 4? 8. And if you check, all we got in that question was 8. Do you see the bad code? Now, let's say, for example, we have a question that was giving 3x. First of all, I check, is the denominator giving 0? If the denominator is giving 0, I'll just differentiate. This become lim. That become differentiate x cubed. What are you going to have? 3x squared plus 0 all over. Differentiate x, we're going to have 1 plus 0 as x approaches minus 2. And this now the same thing as saying lim 3x squared as x approaches minus 2, because 1 means nothing now. So that become 3 into minus 2 all squared. What's minus that? 4. 3 times 4 is 12. Check that question we got. It's 12. Now let's still solve this using that bad code. This one, I don't need to be doing that. This I just go straight. X that become lim. Expatiate this now. Differentiate it. That will give me what? 3x squared minus 0 all over. Differentiate it. That will give me what? 2x minus 0. As x approaches what? 3. So this is same as saying lim 3x squared all over 2x as x approaches 3. So from here now, how do I solve this? This become 3 into 3 all squared all over 2 into 3. That become, what's 3 squared? 9. 9 times 3, that's 27 all over 6. And that was what we got. We now said if 3 go here to give me 9 all over 2. Bad code, very cheap. Do you feel the bad codes? Use the bad code only when you have denominator at the 0, at the base. So if you have 0 at the what? At the base. If you have 0 at the base. Now listen to me. Go to my note. This is only on normal limit. On that normal limit, I have about 15 to 20 questions there. Don't solve. Go to the notes now. Go to the note that I'm saying you. Master this first one before you move to the next one. What's the next one? We're going to be talking about your limit at infinity. Before we talk about limit at infinity, go to that note, solve all, and get it. I know you're going to get it. I'll see you at limit at infinity, which will be our lesson 3. But for now, peace out. Bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.